I'll spend the next approximately 15 minutes in going through what has happened and what are going to happen in the North Sea over the coming 2 decades, and how the North Sea has been seen by the European Union in total as an extremely interesting place to develop offshore to very high level of capacity. And let's jump into what's behind the development in the North Sea, and what could in the future maybe also be more realistic also for the Baltic Sea. The EU strategy and framework for offshore wind is put together of a lot of bits and pieces decided in the European Union over the last 3 to 4 years' time. We have a European Green Deal saying that the European Union should be carbon neutral by 2050, and that requires, as we all can know and can guess, a quite significant amount of renewable energy to be established over the next 25 years. Then we have an EU strategy for energy system integration. How can we integrate the energy systems in between the sectors in the energy sector, but also between the countries, so we have more cross-border cooperation and exchange of energy. Then we have an EU hydrogen strategy, which pave the road for how to develop Power-to-X, e-methanol and e-ammonia solutions in the future. And all these three has been agreed to in the last 3 years' time. And then we can put together a number of directives laying behind and being updated over the last few years' time, and some of them are still in an updating process. We have the Hydrogen Directive, Renewable Energy Directive. We have electricity and gas markets. We have Trans-European Transport Energy Networks regulation. So that's a lot of bits and pieces that are paving the road for much more green energy. If we just take a look on the graph here to the left, you can see the blue dots. That's the offshore wind that has been built out in the countries around the North Sea by 2022, beginning 2023. So you see a relatively small amount, if we take it in that way, small amount of offshore wind capacity, but nevertheless, we do have something like 20 gigawatts installed in the North Sea right now, so it's pretty good. What has been agreed and planned for is the orange dots here, which will end up in something like 66 gigawatt by 2030. That means already in 6-7 years' time from now. And one could ask, can the supply chain really live up to that? And that's a big question. But then the plans for the 2050 development says that we by 2050 in the European Union should reach a total of 300 gigawatt, and most of these 300 gigawatt is planned to be in the North Sea. And in fact, the countries around the North Sea, they have calculated that they alone could install these 300 gigawatts. But there are some portion dedicated both to the Baltic Sea and to the Mediterranean, and a bit to the Atlantic coast along France and Portugal. But new interesting developments was made last year, where few of the partly the EU in the February launched this strategy for the 300 gigawatts, but later the same year the EU and the ministers of Denmark, Germany, Belgium, and the Netherlands agreed another goal, saying that these 4 countries alone should have 65 gigawatt up running in 2030, and that's half of this orange dot here. So. And they should have 150 gigawatt by 2050. So it's a huge build out. And later the same year, the ministers of Poland, Germany, Denmark, Sweden, Finland, Estonia, Latvia, and Lithuania signed an agreement saying that they foresee or they plan to have close to 20 gigawatt built in the Baltic Sea by 2030. And today there's only 2.2 gigawatt in the Baltic Sea. So it's tenfold what we have today to be built in the Baltic Sea. So it's a remarkable development that we look into for offshore wind in both the North Sea but also in the Baltic Sea. But why do wind have such a high interest for all the developers and the countries in the North Sea? We have here a number of aerial maps showing some of the issues we have. We have water depths, relatively low waters, which range between 8 meters close to the coastlines and up to 50 meters out in the central part of the North Sea. And these water depths made it imminent, and it's sand bed all around the North Sea. So these conditions made it imminent to have monopiles installed, which is relatively easy, and we have a huge supply chain delivering monopiles. If we look at the full load hours in the North Sea, we can see that especially in the Danish and the Norwegian sectors, but also in the German sector, we have relatively high number of full load hours, and also along some spots along the Scottish coast and the British coast, we have high full load hours, which make it imminent for offshore wind. And what we can see is that approximately 70% of the, or no, 90% of the time during the winter months, we have relatively strong and good winds. And 80% of the time during summer months, we have good winds patterns also in the North Sea, which makes it an imminent place for wind utilization. And the North Sea is probably one of the best wind spots in the world. So that's why it's so interesting. And if we compare the offshore wind with wind development in other parts of the world and look into the levelized cost of energy for the offshore wind in the North Sea, you can see that they are relatively high, significant high in some areas in the middle of the North Sea, while the LCOE for many other wind spots around the world will range in this area down here. And if you then look here, you can see where the present defined licenses is located. So they are located in these areas where we have high number of full load hours, we have high LCOE, and we have relatively low water levels. So that's why North Sea is so interesting for developers and so interesting for the national authorities having the wind developed in the North Sea, and that's why we have this huge potential. And when it comes to that, then I can tell you that the North Sea is also quite populated already today by oil and gas platforms that will have to be dismantled in the coming decades. There's a huge number of marine pipelines, oil and gas pipelines, telecommunication cables, subsea cables, power cables between the countries. So there's been a lot of development, and there's a lot of issues that can be further developed. In Denmark, the government and the parliament took the decision in 2021 that we should build an artificial energy island. And if we go back here, the artificial energy island is planned to be built in this area here. And yes, we are sometimes laughing of the distance between the coastline and Finnish offshore wind farms. We talk about 100 kilometers here, so that's another story. The plans for this energy island, this is a sketch of how it could look like. The first plan is that it should be capable of operating 3 gigawatts wind farms and wind power capacity, and to be built up to 10 gigawatts in few years' time. and that the island should be operational by 2032. There are still analysis ongoing how to make the business case interesting and operational, because the Danish government have decided that they should be part owner of this island with 51% of the ownership, while private developments should invest in the island, build the island, and have 49% ownership, and then have a business case that could pay back all the investment cost point. And they're still dealing with how that can be made beneficial for the developers. Interesting enough, this initiative have resulted in that both Belgium and Denmark now are working on energy islands. And besides that, Germany has over the last 8, 9, 10 years established 11 offshore HVDC converter systems in the German sector of the North Sea. HVDC converter system that collects the power from between 1 and 3 offshore wind farms and route it to a converter station down in the German mainland, where it's then transported further down south. If we look at this energy island for a moment, it's a bit challenging to build an energy island, and 10, 12 gigawatts wind farm capacities that far from the coastline, approximately 100 kilometers. We are in the place of the North Sea where the wind conditions are really good, hard, strong winds. We have water depths of approximately 30 meters, so we have to build an artificial island on 30 meters water depth. An interesting topic. And we have significant wave heights of 10 meters. We have to calculate with that. But saying that we have significant wave heights of 10 meters, then we also know that under some conditions we will have a max wave height of up to 20 to 25 meters. So this island should be able to withstand these strong forces. Then we also have to calculate with something like 85 to 90 power cables going in and out from this energy island. There will be a lot of cables from the wind farms going into the island, and there will be power cables to be routed down to the countries around the North Sea. The investment, significant, approximately 32 billion euros, where the wind farms alone take approximately 45% of that, but the energy island and the transmission equipment take the rest. There are a number of alternatives which is in focus. They have different benefits, but also different challenges. The Belgian island under design right now looks like this. The suggestion to the Danish island looks like this, or like the picture in my background here. What they have done in the German Bay is developing this kind of structures. So there are different options here. But why is the North Sea? What's the future look for the North Sea? The future, the vision. We have the vision, and the vision have been there among the TSOs for a couple of years, and also some researchers. And that is to build up a huge grid of energy islands in the North Sea, and the energy islands should connect the countries like central energy hubs where you can take in the offshore produced wind power and then distribute it to the countries, like in the spiderweb, or through other of the energy islands to other countries. And you can go both ways. You can also transport from one country through some of the hubs to another country. And that's in fact what is under development for the Kriegers in the Baltic Sea between Denmark and Germany right now. And then also to introduce hydrogen, having hydrogen produced out at the sea together with some of the energy islands hubs, maybe create dedicated Power-to-X islands and then produce the hydrogen out in sea and transport it in hydrogen pipelines to the coast. That's the future, and that's where we think that the situation will look like in the North Sea by 2040, 2045, 2050, around there. So, thank you.